Hey everyone, welcome back. I'm Alex Noonan, and today we're continuing our economic data project. So far, our project is a little bit of data from the Bureau of Labor Statistics that we're pulling into our DuckDB database and then serving in our evidence project. But that doesn't really tell a coherent story about the real estate market, which is our ultimate goal here. And additionally, we don't have any automations in place that we can have these scripts run continuously. I want to be able to tell a comprehensive story about the real estate market in the United States. And to do that, we need more data. Fortunately, everything we need is publicly available, so it's easy for us to pull that in to tell that tale. Additionally, we're going to upgrade some aspects of our data stack. Additionally, we're going to upgrade aspects of our data stack and evidence project. So I'm going to change the Python script to use polars instead of pandas. We're going to use MotherDuck as our data warehouse, and we're going to orchestrate our pipelines using GitHub Actions. Finally, we're going to create a landing page in evidence and a raw data export page as well. So the St. Louis Federal Reserve is a treasure trove of publicly available data. And it's one of my favorite sources to use for these kind of like toy projects and like proof of concepts, because you have API endpoints you can hit and the data also updates. So you get that element of recurring a recurring concern, which is something that data engineers deal with on a regular basis, and often what you don't get if you're working with like static data files. So let's jump into this. We have this function here that takes in the series and an API key. We create the request here, returns a JSON. We take that JSON object, convert it to a data frame, drop some columns, and then we do some type conversions here and drop any null values, and then we return the data frame and print how many rows it's in. And then the main function in this file takes a series of codes and what the name is, loads in the environment variable for the API key, which you can get on the St. Louis Fed's website. And then it just goes through all those series and upserts the data into our DuckDB database, and then it shows that it ran. So this upsert data function is in our utils file here. So let's go in here and take a look at that. And basically what I added in here is first it connects to our MotherDuck database, which I'll get into later. And then there's a few like different like database operations here, where we pull in a data frame and then we just drop create database table. Same thing for loading like a CSV in, polars, data type conversions. And then finally, this one has a upsert data function. So if you want to like maintain the rows in your database and you just want to insert new ones. So yeah, and then we also have in the Bureau of Labor Statistics, we have our same housing inventory function from earlier. And then I have this housing pulse survey data, which this one is cool because with economic matters, things are often vibes based. And this is a survey that goes on every 2 weeks that the government does. And they basically get like a vibe check from people on the economy. So that'll be useful for kind of checking like sentiment from where the real estate market's at. And for the realtor data, this one is in our data folder here. And the realtor.com has these like pretty cool CSVs. Some of these are massive because they go from like the country level granularity all the way down to zip code with history on various metrics going back, I think like 10 years. So these are kind of big. So GitHub Actions are generally for part of your like DevOps pipeline, but because they spin up a virtual instance and you load in like a Python image to do these, you can kind of do some light ETL data work with them. And like as far as an orchestrator goes, it's not robust in the sense of it doesn't understand the state of your platform. You're kind of limited on what you can do scheduling wise. So I have a few workflows in here. So everything's in YAML, runs pipelines on a schedule. It pulls in some environment variables that I set as secrets on my GitHub repo. The jobs in here are to run the scripts, like builds the environment, installs the Python dependencies, and then it just runs through the Python scripts. And if one of them fails, it'll just continue going. So let's see what it looks like in GitHub. So to enable actions, you need to go into your repo settings. And then, yeah, you have to allow actions here. And then for the secrets, it's in this tab here. And you can save them here. And then they're secure. And then your actions will be able to read them into your project. It's kind of similar to using like an environment file on your local machine. The functionality is the same. So let's take a look at the action here for running on a schedule. So it ran successfully, but did it? And it shows the duration here. So we can go into the logs here, and it has the various steps in the GitHub action. A word of note: when you're developing with GitHub Actions, like it's entirely common to see this here, and it's a pretty common user experience where, like, as you're debugging and trying to get it to work, you'll see like a ton of fails. Everybody knows DuckDB, everybody loves DuckDB, but sometimes you need to have a cloud data warehouse. MotherDuck, I've really enjoyed the experience so far. It's got this cool UI. It's really simple to use. It's all in DuckDB syntax. Having that kind of seamless development from like local to a cloud production environment is really beneficial for a lot of analytics use cases, because you're able to like test, develop, run locally, push to cloud, and everything works seamlessly. So plowing ahead into our evidence project, something that I want to see, because real estate is definitely a geospatial domain, I want to allow the user to select a specific metric to display on a heat map of the US. And for the supply and demand elements, I want to have a heat map table that shows the latest value, the percent change from 3 months ago, 6 months ago, 9 months ago. And I think that will be beneficial to see, like, these are the things that are driving price. Let's do some data exploration for the state level data and see what we have. Yeah, so we have the month here, we have the state ID, median listing price. And yeah, we basically have all the metrics we need already calculated. So that's great. But if I just want to see like year over year, I'm just going to pull the max value for this date field. So yeah. So the only transformation we're going to have to do here is we need to convert this text to a proper date field. And yeah, for stuff like this, I always just ask AI, because doing that manually, I don't know, I don't want to think that hard. And so we're also going to pull in these columns. So we want the state and then some high level metrics here. And then I don't like when my SQL isn't formatted properly. Okay. I'm a big copy paster, if you can't tell. And then we can just have this kind of heinous where statement where we're just pulling the max value from that table. And then we'll run this, make sure it works. Okay. Yeah, this is exactly what we want to see. These are cast as numeric values already, so that's great. And so how evidence works is when you configure a source, is you have these raw files associated with your source. And these are just SQL files. And for many of these tables, it's just pulling right from this one. This one I did a little processing, just basically doing the same query we had in the table there. And then, like, if you want to use multiple queries across different pages, you can have this queries folder, and then you can group them into like proper queries here. So the maps one, we have our state map data, and that's just selecting star from our query that we just created. Let's just start evidence. And I like doing it in VS Code because it's faster instead of writing all these commands. So let's fire up evidence. So the queries at the top, this is what I was talking about earlier, where if you wanted to reference queries within your queries folder, you can just do that like so. And then you define the data model here So evidence will cache these on the pages. Yeah, so we have our state data inventory and then our Fred data. And for the state data, I want all the different columns here because I'm going to put those in a drop-down list that the user can select. And that's what we're doing here. So to reference a query, you do that like so with these curly braces. And then we have, I set a default value so the map will render. And then I'm printing that default value here just cause. And then for the map, you need to define one field for the value. So what I'm doing here in the query is I'm selecting the date, the state, and then whatever column the user puts into the dropdown here, it changes the heat map on the map here. So that's pretty cool. And then for our supply and demand data, let's go through and build that query in here. Let's take a look at our Fred table and see what we're working with here. So all the fields are smushed on top of each other. They're at different grains. Some of them report on a weekly basis, some a daily, some quarterly, some annually. We have the value, the series name, and the series code. What I am going to want in this table is the latest value and then how much it's changed over the past 3 months, 6 months, a year, and then like if it's related to supply and demand. So to do that, first we kind of need to determine like how we're going to do the calculations. So to figure out the grain, to determine the grain, I want to see how many different values we have over the past year. So we're going to count the number of rows. Then we're going to have a case when statement. And this is just something, this isn't an exact science. I'm just kind of like experimenting here. But this seemed to work out all right. When count is, if it has greater than 200 values, we can assume that's a daily series because they don't collect it on weekends. And that's for something like the Dow Jones that has that price history easily recorded each day. And then for weekly, yeah, more than 50 because there's only 52 weeks in a year. And then monthly, I'm just doing 9 in case there's any weird date values. And then quarterly, and then finally annually. So we'll do if it's greater than equal to 1. If I could spell. Okay. And then we'll just have a catch-all else here. And then we want to group by series code, series name. So what happened here? Oh. Yeah, so we have some cool date grains over here. So we got some daily values. That's probably not right, but we can deal with that later. So we should have a where statement in here to just filter by the past year. Where date is greater than equal to current date minus interval. Yeah, that's more correct. Okay, cool. Yeah, so now we have a good idea of what our different date grains are. And for the calculations here, I'm going to use a window function, which is one of my favorite, and it's perfect for doing these like time series calculations, especially for the percent changes, which is like the main metric you want to focus on for stuff like this. So we need to have a kind of CTE going on here. And for that, I'm not going to type out the whole thing because it looks like it's 100 lines, but I'll paste it in and we can talk through it. Yeah, so the first thing we do is we're getting the date bounds, and then we're getting the series dates, and then the previous date, and then 2 events ago from these window functions. Then we're doing that date grain process here, which is categorizing the different series. And then we're doing some aggregates. So it's pulling the month out, and it has the date grain, and then it's doing the average of the value. So this way they're all sort of aligned. The only one where this won't work for is annual. But like if we have a daily series, we can just pull the average, and then we're doing consistent calculations across the different time periods. So we got the 3 months ago, 6 months ago, 12 months ago. And then we have the calculation view, which is doing the percent changes and pulling in the values as well. And then we're getting the max date here. And then this is our final view, which we have our calculations. It has the date grain. And then we're also pulling in the max date. So it's just showing the top of the table. And then let's run that. Ta-da! So we have the latest value and then the percent change over time for these. So this is exactly what we want on our table. So back into evidence. Yeah, this evidence project is kind of getting a little unwieldy, but that's how it goes. So we have all the different queries here that we're going to use in our project. And then the first thing I want, and then for supply and demand, I just have a simple case when in here that pulls in that data and then categorizes if they're supply and demand, unions them together. Yeah, it serves this table here. And this is something I want to do as like a heat map, which they have in evidence, but I just use a data table for now. So one can see. Yeah, so I have a to-do here where I'll have a supply and demand heat map with the following time series for each. And then the data export is like kind of the cornerstone of every BI tool. So in here, I'm pulling in the raw data for the main tables. I'm not pulling in the real estate data yet. Or the realtor data yet. That's a future problem. But for here, we have our like schema of tables, and then you can select the table you want to download, and you can just download it from here. And how that's done is pretty simple. Like these are basically hard coded in for the different table names. I think in the future I'm going to have like an information schema query that just pulls all the raw schema tables and allows the user to download them here. But this is a pretty cool functionality. What's cool about evidence, and I've mentioned this before, is the composability is like really powerful as a feature because you can really do whatever you want and you're not like hemmed in by design choices by the software developers. And for doing like data analytics, especially in production environments, there's so many corner cases where you need to have that like code first approach to get around those issues. And this data platform is really coming together. And but I won't be satisfied until we use every single cool open source tool out there. So there's more to come. With that in mind, now we have automated script process to run these data pipelines and a cloud data warehouse to store them, so we can query our data as needed. The next step is add a transformation tool to the mix. If you look at the queries in the evidence project, it looks suspiciously like a DBT project where you have different sections there and they're dependent on each other. So that's the next thing we're going to incorporate. Additionally, trying to orchestrate all this properly with GitHub Actions just isn't going to work, especially once we have the live app, because you really want to be able to monitor and make sure everything is going properly. So obviously, we're going to incorporate Dagster as well as our tool of choice to do that orchestration. And DBT and Dagster work great together. And then we also need to kind of finish these data visualizations and do more analysis. So that's what we'll be doing in the next video. And as always, the project link is in the description. And make sure you like, subscribe, and follow me on LinkedIn, Twitter, and now Blue Sky. So thanks for joining, and I look forward to seeing you in the next one.